name's Steve Muckle. I'm a Linaro full-time employee, and I've been spending some of my time over the last 6 months trying to be able to get some decent performance and power numbers on Android for benchmarking our changes to the Schedutil governor. So if you have worked with me at all over the last few years, so before I joined Linaro a year ago, I was at Qualcomm working on the same exact stuff, doing working on our big little scheduler there, and also the enhancements to the CPU Freak governor that we were using at Qualcomm with using the scheduler information. And something that has sort of frustrated me for a long time is being able to easily quantify the benefit of our changes on, in real world scenarios. So this presentation is kind of my story about my effort to do that as a community member, as someone without access to the benefits that the big corporations have. And I certainly am not making any guarantees that this is the best way to do it or that it even works, but this is what I've got, and I'm hoping to maybe start a discussion about how we can make it easier for community members, people out just doing this in their spare time or for whatever reason who don't have access to the fancy platforms to be able to get in, because you really need to be able to do this to be part of the development effort, I think, for the scheduler, for CPU Freak. So it's a two-part presentation, so I'll talk about how I kind of, my sort of rudimentary approach to creating a suite for this, and then I'll compare. So I've been working on Schedutil as well over the last 6 months, and I'll talk about, so I've compared that to the interactive governor, and then also to Sched Freak, which is sort of an earlier incarnation of Schedutil that recently got merged into AOSP. So, I mean, why do I think, I guess, Android is so important? Why is it worth, bringing this up in the community, and I think putting effort into getting people better support for doing these tests? And this is going to be obvious to a lot of people in the audience, but maintainers, I've found, have increasingly been asking for, what's the real world impact of this? I mean, why are we even considering this change? Why do we want to add this complexity for a patch? They want to know what test case is this relevant on, rather than just stuffing in something because it sounds nice in theory. They want some numbers and some data. So, and we have, like RT app to do unit tests, but and this is partly my opinion, I guess, but I don't think that RT app is a good guarantee that things are going to be relevant on Android. These platforms are constantly changing. With every new version of Android that comes out, I mean, it's a very complex framework, user space framework. How do you know that this unit test that you put a considerable amount of effort into to replicate what, say, a browser might do, the various threads of a browser and how they interact? I mean, for one thing, it's very complicated to build a unit test that will replicate that behavior. And then, because Nutella or Nougat or whatever comes out, the next version of Android, they change a few things, and now suddenly your unit test isn't relevant anymore because there's something else in the framework that causes different behavior. So I think just test the real thing. Clearly, Android is the dominant mobile OS. Here's some statistics on that. I don't think we need those to know that. And more importantly, in the mobile space, the perf and power dynamic is so important that of all the platforms we're going to consider on the Linux kernel mailing list, how does this change affect the things that Linux runs on? Android should be certainly right at the top of the list of discussion. So how do we usually do this profiling? It's usually done on internal-only platforms. I mean, if you look at the SOC vendors and the platform vendors, they'll have stuff that's not publicly available. It's done with costly test equipment, stuff that's probably been professionally calibrated, that has a high sampling rate, that's going to get you very high-quality data. They're using product quality software stacks that have been through a lot of testing and tuning with engineers that are basically dedicated for this purpose. And then they've also got benchmarks. They're the SOC vendors and the platform vendors. They obviously know what benchmarks the bloggers and whatnot care about the most. So they've selected a suite of benchmarks that are going to hit home with those folks and do a good job of characterizing the system's performance and power. So, this is kind of, I guess, obvious stuff from the previous slide, but I mean, commercial entities have a huge number of advantages here, right? I mean, they've got armies of people. As I say, I mean, in my time with Qualcomm, I worked with dedicated, separate teams to do performance and power just for Android, you know. So, and then they've got a whole bunch of money that they can throw at these expensive tools. I mean, not only do they have access to these platforms, but they create them, right? So, I mean, they can design platforms that lend themselves to this sort of testing. And then they also are part of a network of connections to, you know, relevant other entities, some of which might be covered with NDAs. And in some cases, they may even be able to affect changes in, say, benchmarks. I think, you know, some of these folks work with some of the benchmark vendors to make changes to make it easier to do this testing. So, you know, here's a quick, I did all of my testing on the Heike platform, and here's a quick rundown of how that, you know, compares to, when I say typical, I'm talking about basically, yeah, what a commercial vendor would do. Obviously, the Heike has the great benefit that it's totally open, right? I mean, if it weren't for that, then we basically couldn't really do anything because, as a community member, because there really is no other alternative. You know, the hardware is accessible and everything is open, including the schematics. But in the other categories, we're facing challenges. And again, this isn't to sort of poo-poo the idea of doing this testing on open platforms. I mean, I'm really here to just try and point out these problems and as I say, start a discussion about how maybe we can do better to get over them or around them. I think I've already mentioned most of this stuff, but the power domain accessibility, what I'm referring there is, yeah, really the ability to measure the separate rails, you know, the CPU rails, and then not have to have the clutter of activity on other hardware blocks in your power measurements. So as I looked to create a test suite, there were sort of three areas I wanted to cover. I separated out UX because on Android that's particularly important, right? I mean, they care about that a lot, so I think it's worth considering that as sort of a separate area of interest. For performance, you know, right now I was just looking for some composite system benchmark that's a good general overview of how the device is doing. They're harder to analyze, which is a drawback. I mean, if you want to take a trace and try and tease out, you know, hey, why did my change, you know, make Antutu go down 100 points? That might be kind of tough because you know, Antutu does a whole lot of different things, or Geekbench or whatever. Also, the challenge that I faced here really was licensing. I mean, in fact, I started out with Geekbench and then discovered that it's got a you know, license that's a bit costly. So Antutu seems to be free. If someone knows that that's not true, please tell me. You know, and it measures a few different things. In the future, I think I'd like to do some I/O and gaming testing as well. So. Janks, again, I think a lot of you folks in the audience probably know what this is, but you know, the UI in Android wants to run at 60 FPS, and they have a good video here that explains why that number is significant and why they want to achieve that number. When you miss a frame, they call that a jank, and something in the display pipeline took too long. That can be for various reasons. You know, one of the most relevant for me is that the CPUs weren't running fast enough. The governor hadn't sped up the CPU fast enough. But there's other reasons too. I mean, the scheduler might have suboptimally co-scheduled a couple of tasks on the same CPU rather than splitting them up, or there could have been something else. So for UX, there's a recent Fling script in the AOSP tree, and this is what I did. I based most of my testing on for UX. It opens up a collection of apps, and then you know, if you're familiar with the recent app list in Android, it opens that up and just flings that back and forth, scrolling amongst those screens and looking for janks. I wanted to try and explore some of the other scenarios with that as well, so I used that script as a template to create 3 other tests based on scrolling an email inbox, opening up the image gallery and, you know, flinging that back and forth, and then also opening up a web page and flinging that as well. Oh, feel free to stop me also if you have any questions along the way. We don't have to wait till the end. And then for the power scenarios, just a few, you know, rudimentary scenarios there that are listed here. I'd like to do email and web browsing as well at some point, but I didn't get to that just yet. So. Camera, yeah, that is also another one that would be good to add. Yeah, definitely. Sorry, and you said a CPU-intensive workload? Oh, yeah, camera being CPU, yeah, sure. Automation is important not only because it, you know, stinks to sit there and do the same thing over and over again, but also for accuracy, right? We want to try and get the same exact flings each time. And also to try and capture the same amount of background activity. This is not a perfect solution. I mean, with Android, there's non-deterministic stuff happening in the background, and so the best you can do, I think, is just try and get the system into this as similar a state as possible, and keep your measurement for the same length of time, and run multiple trials and see how it goes. So for this, there's at least a couple different options here. I went with Workload Automation Suite, I think somewhat to the chagrin of my ARM friends. So they have another solution called Lisa, which you can find out more about from them. This is a bit smaller. It was also created by ARM in Python, and it's got a lot of support for a lot of different workloads. It's very modular, so if you want to add new support for a new workload or for new instrumentation, it's pretty easy to do. And there's some pointers here. So I had to make a few changes, and those are in that Git repository that I've listed there. A couple downsides. These apps change pretty frequently. So like Antutu, Geekbench, all these things, they're updated all the time, and the support for that in this suite breaks frequently. And so you go to run that, and you probably have to make some changes if it's if you're trying to run the latest and greatest. And I ran into that as well. Also, the stuff in there, I think, assumes a stock Android, Google Android experience. That was not, what we have on the Heike keyboard. So I added some support for using things like VLC or other free alternatives that I installed in my environment. So on to some other challenges. One of the things with the Heike keyboard is it doesn't come instrumented for power measurement. You have to do that yourself. You have to solder on some leads and a connector. There is information on how to do that in the documentation, but you got to be careful. So I was working on a different board, which I won't name, but the instructions that came with it were not correct, and I mean, I think if I had actually looked at the schematics, it would have been fairly obvious, but I didn't, and I just followed the instructions, and I actually blew a trace on the board, and fortunately didn't fry it completely, and I was able to find a different point at which I could, attach this and successfully continue to do measurements. But yeah, I mean, this again, I mean, when you're not, when you don't have the support of a rework lab or whatever, or officially supported internal platforms, this is kind of what you're up against. So. And then there's some other, I mean, when you're doing this again, other things that, when you don't have a lab or a team of people doing this, you've got to handle these things yourselves. And a guy by the name of Andy Green did a great presentation on all the details of measuring power, and so I won't delve into that stuff here, but I mean, here are just a few of the concerns that he explores in that presentation. And then I also ran into some stability issues, both with the target and with the framework, the workload automation suite. I mean, the idea is that you can just kick off this testing and come back an hour later and have a nice pile of results, right, to pour over. In reality, that's not what happens. I mean, even with my, however much effort I put in over the last 6 months, the Heike, it's a community-supported platform, so you're going to get random issues now and then. Workload automation just sort of fails every now and then and stops working, and you have to mess with it. And then the individual tests also, there's some issues there. So, I mean, this is something that really needs to be supported over a length of time. It needs sort of constant attention and maintenance. So with that, I was going to get into my test results. If there's any questions on any of this stuff, I could take those now. One? Anything specific in my device configuration for this? Not that I can recall. I mean, I think it was it's a standard. Well, actually, I'll go to this. Oh, you're getting it. All right. I'll put this over. Yeah, I mean, nothing. I don't think there was anything really particular. It was. I mean, this is the configuration I used. Yeah, I mean, software-wise, it was pretty much just a standard AOSP build, other than the components that I specifically wanted to test. So.
For measuring power on the Heike, as far as I know, I mean, you need to solve the shunt resistors and everything. Don't you think? I mean, a more standardized way to measure power, like 2 pins or 3 pins, just that comes with the board would help, because it's, I guess, I mean, reading schematics and everything is possible, but
yeah, so let me see if I just understand your question. I mean, you're saying, like, wouldn't it be nice if we didn't have to solder the sense resistor and it came? Yeah, no, absolutely. And I kind of wonder why that's the case. I don't know why. I mean, the 96 board standard, I think there's some language in there about, you know, trying to make it easier to measure power, that you should have at least a place to put a sense resistor. But, you know, I mean, I had to go and research, okay, what's the, you know, resistance required for this, you know, particular current and everything, and that's not a trivial exercise. I mean, it's not particularly hard, but you got to dig up that information. Then you got to go find a vendor of your choosing and go to Mauser.com or whatever and order this thing. And, you know, I mean, it's like $1 or 50 cents or something. But, you know, I mean, can we really not just have that? I'm not familiar enough. Actually, it'd be an interesting question to talk to the folks in the 96 boards team, because I don't understand the cost pressures, you know, that they face in getting these boards out there, but yeah, that would be really nice if we could just plug in a header and be done with it. So.
And sorry, another one, if you plan to send the modification to WA that you made, like upstream. Yeah,
so I mean, I sent a couple of my changes, but I haven't been as diligent as I should be. So yeah, I'll send that. Other than posting it, I haven't done much. So I did 2 comparisons. You know, I mean, with EAS getting pulled into AOSP, you know, I wanted to test that tree with Schedutil. So just to give some background, I guess, because not everyone might know what Schedutil is. So, you know, there was an effort in Linaro over the last 2 or 3 years to create a CPU Freak governor that took information from the scheduler and used that to make intelligent decisions about the CPU frequency. That work went on, as I say, for maybe a couple of years. And then early this year, right around January timeframe, I guess, Raphael Wysocki, he created his own kind of version and merged that. It's similar in spirit. It does the same basic thing. It takes information from the scheduler to make decisions on CPU frequency. So I am now trying to move us away from, so the Linaro solution called Sched Freak is what has made it into AOSP. You know, we want to try and move away from that, obviously, over time and get to the upstream solution, which is Schedutil. So that's why I'm doing this measurement, and I want to see how much more work there is there. So with EAS being merged into AOSP, I basically wanted to measure with and without that. EAS makes some changes to, you know, to key scheduler paths and might have an effect on the behavior. So I thought it'd be good to have both sets of data. So the first set I will have is pre-EAS. It's the 4.4 Heike kernel that Linaro maintains with CPU Freak tip backported so that we can use the latest Schedutil patches along with any other framework stuff to CPU Freak in the main line. And then I also have a patch in Schedutil. Right now, Schedutil does a horrible thing with RT tasks. Like whenever you run RT, it just goes to Fmax, which is going to be obviously horrible for power. So I've got a patch to improve that policy, which I pulled in. It's not upstream yet. And then some other dependencies. So here, I put the tuning information in here. I'm not going to run over all these numbers. It's mainly if folks are curious and want to go back and look at these numbers. I think the most important thing is that so I was comparing 3 different governors here, interactive, on-demand, and Schedutil. They're all using a 20 millisecond sampling rate. So that's kind of the most important thing, I think. So on to the numbers. Schedutil, so again, this is pre-EAS, so this Schedutil is just using PELT, parental load tracking.
Would you mind showing the 1T number for Schedutil you had? Can you go to
Sorry.
the previous? Can you go to the previous slide so that I can look at some of the configuration? Not for interactive, for the other ones.
Which one?
Schedutil.
Well, Schedutil is really
Just rate
simple.
limit of it.
So Schedutil just has one tunable which controls the rate. So the upstream folks are really trying to tamp down on the tunables.
Okay. Thanks.
Is this good or? So Antutu actually looks pretty good. The numbers are pretty close. You know, I think at this point, given that Schedutil is not an optimized solution, you know, it's very early. I think anything that's in the ballpark is doing pretty well. And so, you know, I was pretty happy to see this actually. So, yeah, that was pretty good. But then we get into some of the interactive or UX stuff, and it's not so great. So, you know, this is a pretty nasty regression in recent Fling. this percentage is the percent of janky frames that we see out of the total number of frames. So, I mean, you know, these numbers obviously also are just horrible in their own right. I mean, you know, even 18, 14% is terrible, but that's what you get with the Heike platform because it's a non-optimized community platform, right? So, but I'm just having to, you know, the best I can do is relative comparison here and get it as close as I can to, you know, to what's being used generally, so.
Steve, do you know if the interactive for this particular configuration is actually linked with the like touch boost? This,
Sorry, I didn't.
If the interactive governor is actually linked with the, for example, Android touch boost for this particular thing.
We do have PowerHal that does do touch boosting.
So it might be all. Yeah. So I get that link doesn't exist for Schedutil, so it might be.
Here, yeah, so I guess here it doesn't. It will in my next set of tests, which includes John's PowerHal changes, right? So I think with your schedule with your EAS tree, is that true?
So we also added support for the EAS. Oh, sorry. Yeah. So we also added support for the EAS Sched boost or Schedutil boosting.
Okay.
And so that's in the PowerHal as well. So the PowerHal supports both interactive governor and Sched boost.
Okay. Although actually that said though, I think in the testing that I did in your tree, you had taken out that. So yeah, so it's a fair point. But I think for interactive here, it sounds like we should have that boosting, right? In this test. So.
So question on that. So why is boost specific to a governor? Just change them in, no? Why is touch boost specific to a governor? Don't you just change them in? Frequency? Well, okay, yes, get tuned, but.
Yeah, so the mechanisms are different, I guess, between the Schedutil boosting and the interactive governor. And so instead of. Or go ahead.
Yeah, I mean, so the interactive governor, if you go into the tunable directory, it's got a boost and a boost pulse duration and that stuff. Whereas, you know, with Schedutil, you're going to be, well, I guess eventually we'll be playing with Schedutil and those things to achieve the same effect. So, yeah, before I go on, I mean, you know, when I look at this, the first thing that leaps out to me is to why this is happening. It's most likely the nature in which we're collecting the task utilization data, right? So in this test, we're just using parental load tracking, the exponential decay method that's upstream right now. So, you know, will window-based load tracking help? We'll actually take a look at that in the next section. So the tests that I added, you know, I need to spend more time sort of digging into them and assessing sort of their utility. You know, they tell something of a story here, but I don't know that they've been, you know, seen enough action to trust the results or to read a lot into them. But, you know, nevertheless, here they are. So for email fling, it's in the noise. BrowserFling, Schedutil looked good here as well. The numbers are still pretty low kind of across the board. And then again, gallery fling, not much. I actually saw probably more interesting results in the next section when EAS is in the tree. So. And then for power numbers, Schedutil looked pretty good here as well. Actually, it was competitive across the board for all of these sort of basic use cases. So yeah, idle and MP3 playback, and also for video playback, the numbers look pretty good. You'll notice that actually video playback is lower power than audio playback, which, you know, again, here we are on a community platform. So, you know, my audio playback was done using the sort of stock audio player that you get when you install the AOSP, whereas my video playback is using VLC, which is probably a more advanced piece of software that's taking advantage of codecs and you know, onboard hardware, I guess. So. Mm-hmm.
You have any performance data for the video playback? I mean,
performance for what?
For the video playback. I mean.
Oh, like drop frames?
Yeah.
No, I don't. Yeah, I don't have that. So that's a good to do.
Yeah, all these numbers do look close, but I mean, like 19 versus 21, or like, yeah, picking into numbers, it's almost like, what, 5%, right?
Yeah,
5% power in a phone means I'll probably get half an hour more.
sure.
An hour more.
Agreed.
So,
I mean, my reply to that would be, you know, when you're on an unoptimized platform, I mean, you know, Schedutil has seen no, you know, so little effort in development yet. Yeah, I mean, I'm sure you guys are going to come back with 30 patches that make it look like something totally different. But yeah, I mean, to me, this is satisfying to me. I mean, it's something that was just developed in the community without any serious effort on a, you know, like this is, well, I guess.
I'm not saying Schedutil is terrible or horrible, but I just didn't want to call it a small difference. It's a difference that we do still need to address, I think.
So I guess there, you know, there is a discussion to be had on, you know, where are we going to set the bar here? You know, how close in terms of a percentage do we need to be? I mean, in my opinion, you know, if we can get within 10 to 15%, that's probably good enough. And I think at that point, you know, we're going to need more help from SOC vendors and folks that have optimized platforms to be able to get that last little bit, you know. So, I mean, this, I think, for where we're at right now is good. But, I mean, point taken. Yeah, we're obviously not the way, you know, not all the way there. So, so for the second build, thanks a lot to Yuri for, you know, he did the dirty work of merging what I had into the EAS tree and subtracting out the Sched Freak and Schedutil. Sched Freak, again, being the now deprecated version of scheduler guided frequency control. So here the tunables are pretty much the same. Won't spend a lot of time there. So for this set of data, I added in comparing PELT, parenty load tracking, with window-based load tracking. Vikram's going to give a presentation on window-based load tracking next if you want to learn more about it. But it's something that was developed at Qualcomm to basically try and retain you know, the window-based nature of CPU utilization sampling that you get in both interactive and on-demand. We found, I say we because I worked on that also during my time there. We found that was more suitable for mobile and workloads that needed you know, more responsiveness. So, and sure enough, when you look at these numbers, Walt does give you quite a boost, actually, of around 1,200 points in Antutu with Schedutil. So again, I mean, the numbers across the board look pretty good, but Walt does get you closer to what we get with interactive. So. And also with recent Fling, so again, sure enough, Walt does help you there as well. It still doesn't get us all the way down to where interactive is. When I tested with EAS, we're still, you know, like 12 percentage points off, but it got us almost half the way down. So certainly more work is needed there. More optimization is required there.
Hey Steve, one question about the Vault integration. Is that?
I don't know where that's.
Oh.
He just got the voice.
Yeah.
So with the Vault integration, was it purely CPU utilization or was it also task utilization? That was.
This is.
It's both, right?
Okay. Yeah, it should be both, right?
Yeah,
I mean,
it makes more sense if it's both.
So the trial one number so that's performance governor at the end, isn't it?
The bottom row?
Yeah.
Yeah, performance governor, yeah.
So your so trial one, 23% worse than interactive, is that?
Sorry, I'm not following. Yeah, trial one, yeah. So I actually measured worse with performance than with interactive on the first trial. So, you know, again,
Bad sample maybe?
Sorry?
Bad sample maybe? I mean.
Yeah, bad sampling, thermal, random activity on the device, you know, with the Android framework. Yeah, I mean, any number of, and this is kind of what I'm getting at. I mean, I think testing perf and power is often in my experience, almost more of an art than a science. I mean, with the number of things that can affect the device, you know, I know from my experience with teams at Qualcomm that, yeah, they will take a certain number of tests and they'll just throw out outliers, you know, like this doesn't look right, you know, and just take what they see as like the 3 best samples out of maybe 5 or something like that. So how do you know what's considered sane? You know, I mean, that requires knowing a particular version of Android, and everything that's running on your installation. And, you know, so I didn't go through all those steps with this. I mean, just, you know, and again, I mean, this is one of the problems that I'm trying to, I guess, bring up, is that as a lone community member, you know, you can't do that, right? So I don't really know what the answer is there. I think when you look at the average numbers, it looks relatively sane, but you know, ideally this probably needs more trials to weed out things like that. So.
Yeah, it might also be interesting to look at like percentiles I mean, as you're saying, to see if there are outliers that maybe affect the averages.
Sorry, I missed the first part of your
Have a look at the percentiles, like
oh yeah, sure.
just to have a better picture.
Mm-hmm. Agreed. So with email fling again, yeah, with EAS, I actually saw more of a regression with EAS with Schedutil for some reason, and actually, weirdly enough, in this case, Walt actually made things a little worse. Although with differences this close, it's probably hard to read a whole lot into it. But I think you probably can read into this that there is something going on with Schedutil on this particular use case. And here again, I see the same thing with BrowserFling. It looks like there's something going on with Schedutil that Walt did actually maybe help a little bit with. And then with this one, you know, it's interesting because, I mean, without EAS, you know, this looked pretty good actually for Schedutil, but for whatever reason, when we add EAS in there, now I'm seeing a significant regression that Walt actually helps out a fair amount with, so.
It's actually strange because also on-demand, interactive, and perf, they're using basically ES in this case, or not? I mean, did you run all the governors with the new branch, so ES, or are the on-demand, interactive, and perf coming from?
No, this is all with EAS.
Yeah,
this is
so
all
that's what I'm saying. I mean, it's kind of strange that basically it seems that like EAS works fine with on-demand, interactive, and perf in this case, but still we have problems with Schedutil, so
yeah.
Maybe it's an integration issue. I don't know.
Yeah, it needs more investigation.
So why not? So you don't have numbers for Skype Freak?
No, I don't. So
I mean, to compare. Oh, that's your point.
I have those. Yeah.
You have those. Okay.
No, I didn't test Skype Freak. Skype Freak's not upstream. Yuri actually will have numbers on Skype Freak.
Okay. No, but to compare like with Schedutil, right? I mean, everything else is the same.
Yeah, I mean, I don't know. For my purposes, I mean, my goal is to try and get Schedutil, I guess, move folks over to Schedutil. And I don't know, that was the easiest comparison for me to do. I think that, yeah, and also given that Yuri has those numbers, yeah, if you're interested in that, he'll have them.
Yeah, I also share the branch 1 week before coming here, so it's also, I mean.
Sorry?
I also share the branch just 1 week before connect, so
yeah,
it's
there's also that.
But fundamentally, we need to track against Skype Freak. We just need to, because we want to try and supplant Skype Freak and Schedutil.
Right. I mean, this particular test would be very interesting to know what would be with.
So the last little bit I have is power numbers, and here you do actually see that Walt is chewing up some additional power. So in all three use cases, we see that you know, Schedutil with Pelt is in line with the others, whereas Walt introduces a significant power increase. So, you know, I mean, nothing comes for free. You know, in order to get meaningful gains with performance without, you know, impacting power, we're going to need more, I guess, tight integration with the framework to more intelligently, you know, allocate that power to these use cases. So, but if nothing else, I guess it's an indication that at least this test framework is, you know, doing something right. So, yeah. So in all these, you can see. I mean, that one in particular is a fairly nasty regression for video playback. So Schedutil, so these two here. I mean, you know, introducing Walt into Schedutil on video playback gives you pretty ugly power regression. So that is pretty much it. Well, okay, so next steps, yeah, I mean, clearly the framework itself needs, you know, work. As I say, I mean, the stability of being able to run tests. Oh, sorry.
Sorry, can you go back?
Yeah.
pretty close to performance governor.
Yeah, it is.
Just stick with that, man. Problem solved.
No, just the number for perf versus Schedutil with Volt. No, he's comparing Schedutil with Schedutil and Volt. So. Yeah.
Wait, sorry, how is this okay? So yeah, I think Workload Automation Suite, the automation side of this needs work. We're not to the point where you can cook a build and then just set it loose and go have lunch and come back. I mean, it's going to run into stuff. I also see issues with the individual test cases. Occasionally when you're running like the email fling test case, one of the flings will malfunction, and so you're not getting consistent fling behavior across every test. And then, yeah, I mean, there's a lot of data here to dig into. A lot of possible regressions. I mean, there's stuff that's kind of obvious. I think the Walt feature is obviously just moving us into a more performance aggressive space, and my guess is, yeah, the only way to fix that really is better integration with the user space, and then which is Schedutil, right? So that's probably the next step, is to look at integrating the Schedutil feature with Schedutil.
I had a question on the power numbers. So I'm guessing you're taking the power numbers at the battery?
No, so sorry, I should have spoken to that. So thanks for asking that question. So this is a measurement of the SOC. So there's some resources that are excluded from that. I think like HDMI and USB power are not included. The Wi-Fi is off. I don't know if there's anything going to that. But yeah, it's at least a little bit better than battery power. So, and it's measured using an ARM energy probe. So,
thanks.
I think the fact that, like Andres pointed out, that the power was so close to performance, it seems like there might be an integration bug, right? Rather than
an integration issue?
Yeah, for Vault with Schedutil.
Okay. Yeah, I mean, we certainly can look into that. I mean, the numbers seemed believable in other test cases.
Okay.
I mean, I did double check just the basic configuration of window-based. It's the 5 windows, max of recent and average.
Okay. So
that stuff looked okay. But yeah, I mean, that test case will have to be investigated, and I guess we'll find out what the issue is. Let's see, so that's it. Are there any other questions I can answer? Yeah, actually I can just.
Yeah, I came a little bit late. I don't know if I missed it. All those tests you're doing, like email flings and BrowserFling, are they set up some kind of automated tester framework, or I assume you're not a hand fling every time?
No, yeah, so that was covered a little bit earlier. So I'm using Workload Automation Suite, and then there's a script in the AOSP tree called recent fling, which opens up a bunch of apps and then flings amongst them in the recent screen. And I've used that as a template to create several more test cases for this. It's worth mentioning that the recent fling app also relies on some non-free Google apps. So I've modified that a little bit to launch their free equivalents from like F-Droid and things like that. So. Yeah, so the workload automation repo that I mentioned back here, so that last line, if you fetch workload automation there, it'll have those use cases in there.
And I kind of missed the discussion earlier on touch boost being there for interactive. Is it also there for Schedutil in your all test cases?
No. So
okay.
yeah, it
so
won't have
interactive
that.
is kind of getting an unfair advantage in terms of performance, right? Okay, thanks.
Yeah. Any other questions? Great. Looks like we're done. All right. Thanks, everyone. Appreciate it.